Today we'll start with DMA. DMA stands for Dynamic Memory Allocation. Dynamic Memory Allocation. Okay. So what DMA means is like when we don't know the size of the elements, then if we use an array and if we use an array with a initial size, let's say I am going to add the students to the batches. Okay, so if I make a integer to store their roll numbers, okay, so I say 5 students. So I have a capacity of how many? 5. What if the 6th student comes? Now what to do? Now stop the server, come to the program, make changes, do a rebuild, then deploy the new code to the server and then start the server again. Then let's say I increase from 5, I increase to 10. So I stop the server, came here, change the size to 10. Then in the for loop, wherever I had less than 5, I would have do what? I had to come and do less than, do all that changes. Okay, then now when the 11th student came now, again this activity, so these are called as breaking changes. Your code has to be rewritten. Okay, so your code should be seamless. Irrespective, I have 2 students, so I have 100 students. Once I deploy the code, that code should work uninterrupted. Okay. Okay, then I assume, okay, let's keep an array of substantial size 1000 only. Why to come and change the code every time? Just keep an array of size 1000. So now if I have only 5 students, I am wasting how many memory locations? 95 into 5 for each integer. So how much? 400 minus 20, 380. 995. How many? 995 into 4. That is 9800. I am 9980. Right? I am using out of the 10,000. I am using only how much? 5. 20. So how much am I wasting? 9980 bytes are being wasted. So if I declare an array of a substantial bigger size, I am wasting the array. So the people have come up with a concept of dynamic memory allocation. Allocate the memory when the program is in runtime. It is in runtime. So program goes through 2 phases: compile time, okay, and then after compile time it goes to runtime. So runtime is the actual time when the program is running on the server, and compile time is when you are checking for the errors. So we always first compile and then we run. If you go to Turbo C, what you do? Compile and then you run. So compile will check all the errors, program is clean, then only it will go into runtime. So in your arrays, memory is allotted at the time of compile time, because if I don't give a size to the array, the program won't run. So, but in array we have 2 drawbacks, or you can say limitations. So what are the 2 limitations? If I give a substantially bigger size, it will lead to wastage, and if I give a smaller size to save the memory, then it will lead to breaking changes. So when the size and the array is full, then again you have to come and reallocate memory and make an array of bigger size. Okay, so to avoid these 2 limitations, they have introduced something called as dynamic memory allocation. So on the runtime, whenever you require memory, you will be allotted memory by the DMA functions. Got it? So what happens over here is, let's assume that you have made a text box, to-do list applications. People make to-do list applications, so they have a text box over here and they give you a plus button over here, which means what? You need to add. Now how many tasks do you think we can add over here? So if I make, and that will be added to a list. That will be added to a list. Now if I make this list of size 100, means you should at at least add 100 jobs. So if the user only adds 2 jobs, that give clothes for laundry, give car for servicing, and book ticket. This is my today's job I need to do. So how many tasks has he given? 3. So here, as I click on one plus, allocate memory for that task. When I click on second plus, allocate memory for that task. When I click on third plus, now I don't know which user will click the plus how many times. So I cannot predict. So one user who is very busy can click 20 times also. And one user who is not busy will click only once. So when will I allocate? So should I allocate 20 to both? So if I allocate 20 to the one who is using 20, well and good. If I add 20 to the second one also, he is using only 1. So I'm wasting 19. And if I allocate 1, then this chap cannot do the other tasks. You got it? Real world application where this comes into picture. So this plus, you are adding, like you have gone to the passport application. Now it is asking you add documents. So if you have an Aadhaar card, you will add, go to plus, add Aadhaar. Go to plus, add PAN card. Go to plus, add license. So the person who has more documents can add more documents, and who has less will add less. So we cannot predetermine the size of that array which will store the documents. So that will be determined only at the time of runtime. So at the runtime, how do we increase or decrease the memory? For that we have which functions? Dynamic memory allocation. Okay. So it has 4 functions. Like first is malloc. Okay. So what is the full form of malloc? This is the full form. M from here and A alloc from here. M from here and, so what is the full form of memory allocation? Okay. Then, so what this malloc will do is will give you one big chunk. What this malloc will do is this malloc will give you one big chunk of memory. Okay. It will not do the partitioning. It will not do the partitioning. Partitioning will not be done. So it will just give you one big chunk of memory. So let's say if you want to store 5 integers, if you want to store, so how much memory do you need? 20 bytes. So it will give you one big piece of 20 bytes. Okay, so it will give you one big cake, the birthday cake, big cake. It will not do the slicing. So you have to tell malloc how much memory you need, and of that much area it will give you one big slice, one whole memory area of that much memory. So if you are asking for malloc, I want 20 bytes of memory. How many bytes of 20? So what it will do? From 1000 till 1019, right? 20 bytes. It will give you one whole piece of memory. Got it? Okay. So now how malloc works is very similar in a way how you guys operate. Okay. So now in the month of July, what do you all have to pay to college? Your fees. Okay. Your fees. So the college sends you a notification, and they send you the amount also, that this much amount is the fees. Let's say the fees is, assuming the fees is 40,000. Okay. That is the fees for the college. And that very month, OnePlus launches its new phone. Okay. That phone also is of 40,000. Okay. So your college fees also is 40,000. The mobile also costs how much? 40,000. And let's say your friends are planning for a trip to Dubai, and they're saying per head contribution 40,000. Okay. So now when you go to your dad, you want the 40,000 for what purpose? Pay the fees. You are not interested in buying a new mobile, neither are you interested in going to the trip. So now when you go to your dad, you have to answer 2 questions. Okay. So you are prepared with the two questions up front. So you will say how much you want. That will be your first question, because you will tell that I want 40,000. So the immediate counter question will be for what? Because the dad knows that a new phone has also been launched and your friends are also going for a trip. So you will say, I need to pay my fees. I need to pay my fees. So you will be ready with these two questions. How much you want, and or you will say, what will you do with it? What will you do with the money? Okay, where will you use the money? These two questions will be there. So this is a very obedient student. Okay, some rich chap. Okay, he also goes to his dad and he says, what? I want how much? 40,000. Why? I want to buy the latest OnePlus mobile. Okay, super rich chap. He goes to his dad. He says, I want 40,000. Why? We are planning for a trip to Dubai. So we need to pay for the airfare. So yes or no? These two questions understood? So similarly, malloc also works in the same way. So first of all, have you all seen a honeycomb? You have seen a honeycomb? So this is what a honeycomb looks like. Your memory map also is similar. So if you have a 4 GB memory, 8 GB memory, 16 GB memory, internally it has cells. It has what? Memory location. So let's say one cell is of, let's say, 2 bytes. How many bytes? 2 bytes. So I want to store 10 integers. How much do I require now? 20 bytes. So these cells are numbered with the address, right? I had shown you in the tongue of pointers. Okay, so let's say these are the numbering of the cells. So this is cell number 1, address number 2, address number 3. Okay, and if you observe in the honeycomb, some cells they have honey and some cells are blank. If you observe clearly, so somewhat like this. So this darker or this orange colors, these are filled with honey, and these yellow colors are empty. Similarly, your memory map also, you will see some addresses are allotted data. So they have data in cell, and some addresses are free. Some addresses are free. Let's say assuming these all are free addresses. Okay, so this is one. So now I want, okay, I'm just fast forwarding it now. So let's say this is 1 and this is 100. All cell, each will have a different cell number. 200. Now when I say I want to store 5 integers, means how much memory do I need? One integer is of 4 bytes and I require 5. So I need 20 bytes. So it will go and dive in the memory map and look for where I can get 20 as one block. 20 as one whole block I can get of 20. So let's say from 4 onwards I got memory free. So from 4 till 23, right? So from 4 till 23 I got these cells. So it will dive in the memory and check where I'm getting 20 blocks of space, and it will return the address of the first block. It will return the address of the first block. Okay, so now what happens is when I tell malloc that malloc I want how much? 20 bytes. So you have to first tell the size in bytes to malloc. How much bytes? 20 bytes. So first question is answered, Dad, I want 40,000. Second is, what will you do with this 20 bytes? So what do I plan to do? I plan to store integers. So you have to typecast it to integer pointer. Second question. This is malloc, give me 20 bytes. I want to store integers. So malloc will dive in the memory map and will look where it is getting 20 bytes as one full chunk. One full chunk. Let's say if 4 was there and assuming this space was full, this space was occupied. Now will it give me from 4 to 23? No, because in between there is some obstruction. So then it will start coming from, let's say this was 12, so memory location 12. So it is saying from 4, 12 is an obstruction. So I am getting only from 4 to 11 only 8 bytes. So I cannot give this stretcher. So it will go and start searching from 12 onwards. Is from 12 am I getting 20 bytes continuous? One full chunk I want. Getting it? So it will look in the memory and dive, and let's say it gives you that memory piece. How much? From where to where? From 4 to 23, right? 4 inclusive, 23 inclusive. 4 inclusive and then it will make a pointer point over here. It will make a. So my question is, what is the type of this pointer? Integer. So RHS equals to LHS. So I'll have a pointer integer star P which will point to the base of this. This is one syntax of malloc. Okay. So how much memory you want? With 20 bytes I can store 20 characters. I can store 5 floats. I can store 5 integers. So what do I want to store? Well, I can do 3 things, right? With that 40,000 he can do 3 things. But what is he asking the money for? Pay the fees. So he's telling, okay, you give me 20 bytes, I will store integers. So it will reserve this space to store what? Reserved to store integer values, yes. And then it will, the start of that address, the block, a pointer will point which is on the LHS, which is the pointer star P. So now P is that pointer which is pointing. Is this making sense to you all? So okay, so P is a pointer which is pointing to this free reserved area. Now in this area can I store characters? No. So if you take the money for the paying for the exam fees and you go end up buying a phone, so what will happen in the evening when you return home? So you have to keep your promise, right? So can I store the characters over here? No. Got it? Yes, no, maybe. Okay. Second scenario. I want to store 10 characters. I want to store. Then I will ask malloc. Malloc, how much? Malloc, give me how many bytes? Simple. Malloc, give me 10 bytes because I know the table. I know the size table. I know the menu. Okay. So if you go to a restaurant very frequently and you know the rates of the item. Okay. So, and if you go to a new restaurant where you don't know the size. So, okay. So, character is 1 and int is 4 and float is 4. This table is known to you. So when this table is known to you, okay, 1 character, 1 byte, 1 integer, 4 bytes, and 1 float also is of in a 64-bit system, right? So now you are told to store 10 characters. So you know this table. So 1 character is 1 byte. So 10 character will be 10 bytes. So you tell malloc how much bytes you want? 10 bytes. So malloc will now dive in the memory and check where it is getting 10 bytes free in one block. In one full chunk it wants 10 bytes. Okay. So let's say it gets from 200. It gets from where? Rest all are occupied. Okay. So from 200 to where? 209 it will get, and it will return you the starting address. Okay. So it will give you these 10, and so it will go in memory and we'll say, okay, this is the location, which is what? 200, here you can get 10 bytes free. So from 200 to 209, you are getting these 10 bytes, and it will. So what will you store in this reserved for? Reserved for this area, reserved for character. So you have to tell malloc, okay, now I will store what in that. So character pointer. Okay, this is called typecasting. And then you will make a pointer, let's say star q, which will point over here. So what is the type of star q? RHS. So just copy the RHS. Just copy the RHS. What is the RHS? Copy it, put it on the LHS. Put it in the LHS with the name of the pointer. What is the name of the pointer? Q. Am I understood? Yes, no, maybe. Understood the concept? So character star Q equals to, making sense to you all? Okay. Now, if you go to a sweet shop where you know how much is one samosa for. Okay, so one samosa in Mulchan costs 20 rupees. So you would give him 20 rupees and tell him, give me samosa. So you are expecting one samosa. Now if you go to a new shop, now where you don't know what is the rate of a samosa. So you will ask, how much is one samosa? Okay, and you want to buy 3 samosas. So now you don't know what is the, now you don't know, I have to give 60 or do I have to give 75? Is it 20 or 25? I don't know. Some fancy restaurant might sell for 30 rupees also. So if you give 60 and tell, give me samosa, you are expecting 3 and he'll give you 2. Because you are not aware of the rate. So now you are not aware of this table. And I don't know in this system, whether this system is a 32-bit system. Because in a 32-bit system, what is size of integer? In a 32-bit system, size of integer is? So now I don't know this system is 32-bit or 64-bit. So if I want to store, if I tell malloc give me 20 bytes, and this is a 32-bit system, it will give me to store 10 integers. So then what you do, then you use of size of operator. What you use? Size of operator. So I wanted to store 5 integers. So and I don't know the size table. So I will say malloc what is the size of integer in this system? It will say 4 bytes. Okay, 4 bytes. Then multiply that with 5. How much? 20. Give me 20 bytes. Give me 20 bytes. And LHS remains the same. LHS remains the same. That should not be different. LHS and the typecasting remains the same. That should not be changed. That should not be changed. That is the same. Okay, so these two scenarios you have when you know the size and when you don't know the size. Now I want to store 10 floating point values and I don't know the size. Okay, then what happens over here now? Malloc will dive in the memory, look for where I am getting 20 bytes and will make a pointer point to the base of that and return that address to you. And so you can use it to point to you can use a pointer to point to that address. So what will C compiler do over here? Will dive in the memory, will look for a space where it is getting 20 bytes, will take the start of that 20 bytes, return that address to you. You can take a pointer and point to that base address. Making sense? So now I want to store 10 floating point values and I don't know what is the size of a float. So what will I do? Malloc, tell me what is the size of is one word. Size of is and S small, O small, no space. Size of what? Float. Float also small. So give me size of float in your system. He says size of float in my system is 4. So I want to store how many of them? 10. So I want to store 10 floating point numbers. It will go and dive in the memory and look for where it is getting 40 bytes continuously. Let's say it gets 40 bytes continuously at this address, wherever it is. Let's say from address 1000 onward, it is getting 40 bytes continuously free. So what it will do? What will it do? From 4000 onwards, From 1000 onward, it will take 40 bytes. Means from 1000 to 1039, this area it will reserve, and it will be one single chunk of how much? 40 bytes, and it will return you this. And what will you do? What will you do then? Okay, I want how many bytes? 40 bytes. Then I have promised I will store what in it? So I will typecast it to float, because malloc will return a void pointer. What will malloc return? Vanilla flavor pointer. Then we have to convert it to whatever type of data you want. Okay, and then I'll make a float pointer point to it. So in my program, I will use this area as my R. Yes, no, maybe. Got it? Okay. The only subtle difference between malloc and calloc. So what are the functions of DMA? What are the functions of DMA? First is malloc, second is calloc, third is realloc, and fourth is free. Fourth is free. So the only difference between calloc and malloc is calloc goes one step ahead. So if you go to a pizza shop and you order a pizza, and the pizza man says that there are 6 friends sitting over there, so he will make the slices even, that everybody gets equal. Yes or no? So he will make slices in multiple. Let's say they are according to the number of people, he'll make the slice, right? So if 3 friends have gone, will he make 8 slices? Because it will be unfair, right? So he'll be smart enough. Okay, 3 friends, let's make that same diameter. Let's make how much? 9 slices, so that everybody gets 3. If 2 friends have gone, then if 4 friends have, accordingly he will make, right? So if 4 friends have gone, he will make how many? 8. At least they get 4 each. If 2 friends have gone, no point in making 9. Then that last piece, people will be shy that you have. Everybody has the intention of having it himself. Huh? So calloc, what it does, it goes one step and it does the partitioning also for you. It does the partitioning also for you. Okay, this reserved area for integer, of how many integers? 4 to 23 means 5 integers. So it will make the 5 partitions. It will make the 5 partitions. That is called continuous allocation. What is calloc meaning? So it will go one step ahead and make the 5 partitioning based on the type you have given. If I had given character, then it would have made in this 20. It would have made 20 partitions. It would have made 20 slices like a cake. So a big loaf of bread cut into 20 slices. So here, depending on the type you have used, because malloc and calloc will return a void pointer. Will return a void means null. You have to typecast it. So depending on the typecasting, it will make the number of partitions. That's the only difference. So if you are using calloc, so don't say multiply. You can say calloc. Now if you want to store 5 integers using calloc, 5 integers using calloc. So and you don't know what is size of an integer. So what you will say? How much you want? 5, and size of rest remains the same. Rest remains the. So here you have multiply. Here you have, and you can put multiply at the end or at the prefix or suffix. You can say 5 into, or because multiply, it doesn't make a difference, right? So 5 into size of int, or size of int into 5 is one and the same. Okay, but in calloc, the first argument, now it has only one argument. Malloc has only how many arguments? One. These both are same. Malloc has only, but calloc has 2 arguments. First is how many slices you want, and one slice of how much size. So you are saying I want how much? 5 slice and one slice of 4 bytes. So it will make you 4 bytes, 5 slices. That is called as continuous allocation. Continuous or contiguous, whatever. Got it? The difference between them? Continuous allocation. Okay? Understood? And the syntax remains the same. Next, coming to realloc. Okay, realloc, very interesting. So what happens in realloc is, let's say a father and a son, they are staying in one of the costliest or one of the expensive areas in Pune. Okay, they're staying at Bun Garden Road. Where are they staying? Bun Garden, 17 Bun Garden. So there they have a 1 BHK. What they have over there? 1 BHK. One bedroom, hall, kitchen. Okay, so this is the hall. Okay, this is the kitchen. This is the bedroom. This is the washroom. 1 bedroom, hall, kitchen. And this area is a bit expensive. So now the son has become 23, 24, 25 years of age. Now what to do? He needs to get married. But is there sufficient space in this flat to bring the newlywed wife? No. So what do they do? What they do is they break the wall between the neighbor and they take the neighbor's hall inside. Yeah. What so this house was fully loaded. It had a wardrobe, dining table. Okay, all the furniture was there, sofa, and all the utensils, everything what is there in a house, right? Fully loaded, it was there. But they cannot, and they don't have a budget to buy it in this expensive area. So what they do? So if they sell this 1 BHK, will go for 80 lakhs, let's say. How many? 80 lakhs they sell it, and they can get a 2 bedroom for 80 lakhs in a different area. Let's say they shift to Undri, okay, or they shift to NIBM. So NIBM they might get in the same budget. They might get how much? 2 bedroom. So a bigger. So this is the hall. This is the 2 bedroom. Bedroom 1, bedroom 2, and washroom, kitchen, blah blah, X, Y, Z. Okay? Let's not go into the architecture. So now what to do? Will they leave the wardrobe sofa over there? Or what people do? If it is in good condition, what they do? They shift it to the new location. So all this furniture or all that stuff which is there shifts to this location. So there is an extra cost of shifting also. Okay. So all this luggage, so they will call movers and packers and shift this over here. Okay. And now the newly wed wife, her dad has given some furniture. Now where will that go? Where will that go? That new furniture, let's say it is blue color furniture. So that will go in the new house. So whatever extra things which have been bought, so the stuff from the old house will be transported, and then the new stuff will come over here. Getting it? So what was the address of this flat? 17 Bun Garden Road. And what is the address of this flat? Okay, NIBM. XYZ. Making sense to you all? So my question is, has the size change occurred at the very same place, or has it occurred at a different place? So that means the entire data which was there at the current place, is that lost? The data which was there at the current place, at that lost. That wardrobe and sofa has been lost. What has that been? What has happened to the existing data? It has shifted to the, and then whatever new things are to be added is added to the new location. Is it understood? So this is how realloc was. So now I had allotted memory of 10 bytes or 20 bytes. Okay. Now my 20 bytes got full. Now I want to allot more 20. Okay. So at every, so I'm in, when the user clicks on plus, when the user clicks on plus, when the user clicks on that to-do list plus, right? So in each, so this is the list in which I am going to store, and these are the text box in which I will take the item, and here I will have a plus, right? So when the user Now it is blank. So when the first item is added, I will increase the size by 5. So size becomes 5. When the sixth item is being added, I will again increase by 5. So whenever it is full, I will increase by 5. So my memory wastage also is less. So if the user has added sixth item and has then left, so I'm not unnecessarily increasing the size. Only now 4 bytes are wasted. Okay. So I'm waiting for the 5 to be full. Once the 5 are full, then I'll increase by a substantial size of 5. Okay. So now what to do? So let's understand real log. Okay. So is this statement understood? Okay. So we'll just play around with this statement. We'll do the real log on this statement. So this statement. Okay. So by executing this is the situation of my memory, correct? And my P is pointing to, where is my P pointing to? Which address is P pointing to? 4. Yes or no? P is pointing to 4, right? And I'll have to erase these lines also, because these lines are making it look like calloc, right? When I'm using malloc. You can use realloc for both. You can use realloc for both, not a problem. Memory allotted by malloc or memory allotted by calloc. Okay. So now I have one big chunk of how many bytes? 20 bytes and address 4. Now when the user adds the sixth element, can I add the sixth element over here? Can I expand this house over here? Here only. Shift. Now this office is there, neighboring office is there. So I'll break this wall and take that area also inside. Not possible. So the increment is not possible over here. So what we have to do? Go to a new location. So now search over here. So we had 20, now I want to make it 40. Now look over here where I'm getting 40 bytes free. So earlier we were at 4 to 23. Now here it is not possible to increase. So let's say we get the new as 120. Where we get? At 120 I am getting 40 bytes. 120 I am getting 40 bytes. Okay. So at 120 address I am getting 40 bytes free space. And this data had some data over here. Because I am increasing it is full, right? So from 4 to 20 I had to store how many? 5 integers. So these are my 5 integers. Okay. Let's say 18. Okay. Let me take darker color. The background is such that nothing will be visible on this background unless I paint it. Unless I paint it. If I paint it with white, the rectangle paints, right? Let it be. So now I had stored over here 5 elements. So let's say it was 18. So the top order of India, tell me. Virat, Rohit, and how much is going? It is what, 77? Surya is 63, and Iyer and Rahul is 1. So I had stored these values 18, 45, 77, 63, 1. Now I am storing the 6th player, Hardik Pandya's jersey number. I have no room over here. So what do? Transfer it over here to 120. So first thing first, what happens? First thing first, what happens? All this, the storage is increased from 120 to now it was 20 bytes. Let me go 40 bytes means 159. Okay, storage has increased. First thing. Second thing, the existing data is transported over here. The existing data is transported to the new address. So 18, 45, and 77, 63, and 1. And now I have room for more 5 players jersey numbers. So I can store the jersey numbers of other 5 players. blah blah blah, whichever, 1 player, 2, 3, 4, 5, x, y, z. So now what happens is, once I have got this p, now is the p pointing to 4, and there is no room for increasing over here, maybe or may not be, maybe or may not be. So if I have the funds, I'll buy the neighboring flat, maybe or may not be. But let's assuming normally what happens is it goes to the next location. So you will get, when you do the realloc, you will get extension over here only, or at a new address. It is not guaranteed. You may get 1% chances are that you may get the extension at this location only, but not guaranteed. So let's not go into that. Let's take the other route. So now I will say realloc. What I will say? Realloc the memory which is pointed by which pointer? Pointed by pointer P. And now what is the new size? 40 bytes. So I will say what? 10 into size of integer, because now I want to store 10 integers. So this 10 we can have a variable. We can have a variable n which keeps on incrementing. Okay, so you can keep it n. Now my value of n is 10. So now what is the size of, what is this new size? 40. And so it will go and dive deeper and go and check where I'm getting 40 bytes. So where it got 40 bytes for? Which? 120 till 159, and the data which was over here 18, 45, 77, 63, 1 is copied over here, 77, 63 and 1. This data which was over here is copied over here, and now I have to store from which index? Which index can I use now? Now let's say from 0 index till 4 index it is occupied. The same which was over here, 0 to 4 index, right? So now when I will store the next data, I will start storing from which index? From 5 index. 5 index I will start storing the new elements. Okay, so here I will store the next time. Okay, now who is pointing to this 100, 120? So you can use the same pointer also. So you can say P. Or you can take a different pointer. You can take the same pointer, or you can take the different pointer. So if you say P, meaning use the same pointer. So this pointer 4 which was pointing over here, now starts pointing over here. And this is your garbage now. This is your garbage. The memory location to which no pointer is pointing is called as garbage. It's called as garbage. And the garbage collector will come and wipe off this memory. Getting it? So is this understood? Realloc. So realloc the memory pointed by this pointer to this new size. And you can change the name of this pointer. So if you had this, if you change it as star q, so instead of using P, you make a new pointer and you say integer star q. Then what happens? So now if you use this, so this pointer will be q, right? Instead of P it will be q, and this P is pointing to this. So this is not termed as garbage. So you can move the same pointer to the, so you can keep on using the same pointer in realloc. And it will copy the data from the previous location and it will give you this new space to work with. Understood? Okay, now let's say if I use this integer star q. So this P is still pointing over there only to its old location. Q is still pointing over here, right? But I am using what? While reallocating, I am taking a new pointer, right? I am using this. So now what about this P? Is it of any use? No. So you can clear that memory by using the fourth called free. So free and the pointer name which you want to free. So free the memory pointed by divided by p. So this memory is now fit. So this 20 bytes now can be reused. This 20 bytes now can be reused. So these 20 bytes again will turn into yellow color, so that other people can use it because I have freed the memory. So this is the fourth operation. Making sense? The theoretical part of malloc. Understood? Malloc, calloc, realloc, free. Now let's do a small program. Now I want to store 5 integers. Store what? Store 5 integers. So tell me, malloc बोलो. तो पहले malloc के लिए malloc ऐड कर लो. क्या कर लो? Add malloc.h. Okay. Now tell me. So you will say malloc. First thing first. How much you want? How much you want? Now you know in this system, the 64-bit system, it has size of 4 bytes. So you will say I want how many bytes? 20 bytes. Then what will you store this 20 bytes? So you will say I will store integer, and then you will make a pointer which will point to this integer. Is it making sense to you all? Okay, one more thing. Pointer, if it is pointing to a large chunk of data, you can visualize it as an array also. You can visualize it as an array. See, I'll tell you what I'm trying to say. I'll just tell you what I'm trying to show. Why would I want to do this? Okay, you can visualize it as an array also. So what have we done over here? We have done over here integer star p. So I normally write it from right to left. Malloc, I normally write it from right to left. So I write it what? Malloc, how much you want? 20, and what will you do with it, right? So as the RHS is, and this has to be in brackets. Typecasting is in brackets. Typecasting is in brackets. So now what will this do internally? Let's say from 1000 you have got how much? Okay, and till 1019, and this will store how many integers? 5 integers. So next integer will be at 1003, 4, right? 4. Next will be at 1000, 0, 1, 2, 3, na? Next will be at where I'm saying 8 and 12 and 15 to 19, right? And it is the end, correct? So I understood. And this will end at 19, and 19 is the 16. Sorry, 16. My bad. 1000, 1004, 1008, 1012, 1016. And it will end at 1090. Is it making sense to you guys? Making sense, right? Okay. So irrespective now, you all know. Okay. So now where is my P pointing to? So now as it is pointed to a chunk of data, you can visualize this P as an array. Is an array. If this was your regular traditional array, how would it be? Integer P equals to, and let's say if this was the data in that array. If this was the data in this array, so how would this array look like? It would look something like this. Okay. And if the array base address also was 1000, what would be the indexes? 0, 1, 2, 3 and 4. and this will be the data. So if I'm hard coding, it will come like this. If I'm accepting from the user, what will be the for loop? Tell me. For I equals to 0, I less than 5, I plus plus. And what will I do? Scanf percentage D, comma, and P of I, and I'll scan the elements, right? So I'll say enter 5 elements over here upfront. I'll say what? Printf, enter 5 numbers, and this is how I will scan and put them in the array. Yes, no, maybe. The same logic I can apply, same logic I can apply when a pointer is pointing to a block of memory. Same. So instead of using this over here, we can use this over here also. What is the pointer name? P. If the pointer name was PTR, then what would you do? If the pointer name was PTR, then if the pointer name is PTR, what will you do in this for loop? And PTR of I. As simple, just like how an array works, same to same. And what? PTR of I. Same. No difference. Same difference. PTR of I. So, understood what I'm trying to show? If a pointer is pointing to a block of storage, then that pointer you can operate similarly as a array. Same. So where is P pointing to? 1000. From there I have continuous, how much? 5 integers. So I can directly use this PTR as a array. See, I'll show you. So if I tell the user printf, please enter 5 numbers. Now I want to store these 5 numbers in an array. How will I do it now? Tell me. For, let's take an integer I also. Tell me what is the for loop. Tell me. Simple. Just consider this to be an array now. This star P. Visualize this star P as this. As simple as that. Tell me. Same concept remains the same. For I equals to 0, I less than 5, I plus plus, and do what? Scanf percentage D will go where? And P, or the pointer name P of, making sense? And to display them, the same for loop with printf, the same for loop with printf. Yes, no, maybe. The same for loop with printf, and I'll put them on the same line, separated by space, and remove. Yeah. And I'll remove the and. Making sense? So this will accept 5 numbers and display them for me. Simple. Let's run it. And here you go. It is asking me to enter 5 numbers. So let's enter Virat, Rohit, Rahul, Control A, Control C, do a refresh, do a Control A, clear it, Control V, do a rerun. Tell me. 18, 45, 1, 77 and 16. Accepted and displayed. Accepted and displayed. Okay, if you want to go with the conventional, sir, what we did last time around, then what to do? Instead of using this, what you can use? Put it where? At P plus I. Put it where? At P plus I. where at p plus, so but this looks much more simpler, right? This looks much more simpler, doesn't it? Yes or no? So those who want to do with this can do this, and those who want to do with the different, that what we did last time, we can comment this and directly we can say where, put it where, at p plus I. What is the value of I? 0. Where is p pointing to? 1000. 1000 was 0. First number goes over here. Then when the loop increments I becomes 1, next number goes at, so instead of using this, you can use this or you can use this. So either of them you can use, but the array concept looks simpler, I guess, right? Those are comfortable with array. So now if I do, okay, should have taken, I'll stick to both of them, okay? So I'll just comment, it's up to you now what style suits you better. So this, so you can do this, and you can also do this. Let's run it. What happened? What happened over here? Should we have given, what is the error message coming up? Oh, we shouldn't give the and. It's scanning, right? So what will we say? What will we say? And p plus I looks like, and while displaying, what happened? Okay, this isn't working. Okay, let me check this out. What is the logic for it over here? स्टार वैल्यू रहता चलो इसको देखता हूँ मैं फिलहाल तो आपको मैं ये एरे वाला कॉन्सेप्ट बताता हूँ ठीक है ओके इज दिस अंडरस्टूड द एरे कॉन्सेप्ट so also I had done over here I had done over here MPTR of so pointer name is P, right? The pointer is P. Yeah, so P plus I over here, percentage D. And value required as AND. So AND was required. Yeah, so we have given the AND over here. So we can comment this out. Comment this out and say what? AND P plus I, and while displaying we can display value at P plus I, right? This is it. And number 11, it is struggling over here. Okay, so let's try to, okay, so no need to, as it is already a pointer, right? No need to give a AND. So let's say 1, 2, 3, 4 and 5 numbers, accepted 5 numbers displayed using the pointer concept. Yes or no?
Yes, sir.
Now I want to do the same thing using, so which one do you all want to stick with? The array one or the non-array one? Array concept is looking easier to me. So just stick to this, and this we can comment. This we can comment. Okay, so now I am sticking to this style. Okay. Now what is the base address of this P? If I want to check that, then the base address of this P, if I want to check, what will I say? Printf address after malloc percentage p comma p. Okay, making sense? And then slash n. Alright. So it is showing me what happened. Percentage p for pointer. Percentage p for pointer. When you want to display the address, you say percentage p slash n. Then you get I, you get p of I. Then you are scanning them as, okay, this, and then you put a for loop again and you printf them as p of I. Yeah. And now what is it asking? At line number 11 and 13. What happened? 11, what happened? You got extra bracket. Is it? Okay, this wasn't required. Okay, this was the problem it was creating last time. Okay, now looks good. So it's telling address after malloc is what? 2AO. Okay, and I'll put the numbers now, and you get this. Okay. Now if I were to do realloc, okay, then what will I do? Once I have displayed these 5 numbers, okay, I'll do what? Realloc which pointer? P with what new size? Size of integer multiply by what? 10. And which pointer should point to it again? P should point to it. So those 10 are copied, those 5 are copied. Now what is left now? The remaining 5. So now if I want to accept, my index will start from which index? My index will start from 5 and will go till 10, because I already have taken the 5 which I have copied down to the new one, and the new indexes will be from 5 to 10. And now I ask enter the new Jersey numbers. Okay, yes or no? So we are asking enter the Jersey numbers of top order. Enter Jersey numbers of top order. So they entered the Jersey number of top order. Now once top order I have got, now I'll order of middle order. So middle order will start from okay, this I am displaying over. This I am displaying. Now yeah, after realloc, I will ask for the Jersey number of middle order. Will start from, will go to less than 10, and I will accept it. Okay. Now if I want to display all the players, then what will I say? Now if I am the scanf is okay, this is scanf, right? So this will be scanf percentage D and P of I, right? And now I want to display all them. So I'll copy this printf. This is displaying only the top order, right? Now I come down and I display from where to where? 0 to 10. Will display me all the entire team, right? Printf team. Okay, let's run it. What happened? So now let's enter. This is the new address. Okay, now I want the new address also. After the realloc, I want to display the new address. After this was address after malloc. So will the address after malloc and realloc be same? Will the address after malloc and realloc be same? No, right? It should change. Address after realloc. So it should tend to change. Let's check it out. So the address after malloc is ending with 2AO. Okay. Now I enter top order Jersey. So I start open with Rohil and Gil. Virat comes 1 down, Rahul comes 2 down, and let's say who's there? Iyer. What is Iyer? 60 63 है क्या Iyer? तो ये मेरा टॉप ऑर्डर हो गया. अब देखो अभी what happened? एड्रेस चेंज हुआ कि नहीं हुआ? 2AO था, अभी क्या हो गया? AEO. AEO पे ये सब आ गए और अभी किसका ले रहा हूँ मैं? मिडिल ऑर्डर का. तो लेट्स सो मिडिल ऑर्डर 10 20 30 40 और 50. तो पूरी टीम जर्सी क्या हो गई? 45 77 18 163 10 20 30 40 50. Understood? And now if I would have changed the pointer while doing the realloc, if I had realloc I would have changed integer star q. तो p कुछ काम का हुआ, इसके बाद p को क्या कर दो, फिर p को फ्री कर दो ताकि मेमोरी कोई और यूज कर ले, और यहाँ पर फिर किसको खेलो? q को. और इस q पे p का डेटा आ चुका है, ठीक है. Now let's run top order. ये 2AO आ गया. So let's say 1 2 I'm taking simple numbers, okay, 3 4 and 5. So here double free detected in double free. Why is it double free? Why is double free? Free P, yeah. Okay, let's comment out free for the time being. Okay, free is the most easiest command to learn. So top order is 1 2 3 4 and 5. Okay, why 2 free means when we got from P to Q there was no pointer pointing to P, so it actually got free internally, and we are doing it externally free also. That's why double free. When there is no pointer pointing to a block of memory, that is termed as garbage. The garbage collector will come and internally when it is being freed, and we also freeing it externally, so it is telling double free. Okay, now 6 7 8 9 and 10. Okay, so when I change the pointer it is still showing me all this stuff. Got it? Understood all the 4 commands thoroughly? Yes. Umar, tell him double free.